We've mentioned before that proportional relationships can be represented on graphs. So it's important for us to be able to identify the different types of proportional relationship and the graph associated with them. Let's look first of all at the simplest proportional relationship, direct proportionality. In this, y is proportional to x. We use that little symbol to represent the word proportional to. So y is proportional to x is a direct proportional relationship, and it can be represented by the equation y is equal to kx. And you should be able to recognize this as a straight line graph. And in this equation, k is the constant of proportionality. All this is a straight line graph where the line goes straight through the origin, and k is equal to the gradient of the graph. It's possible to use these kind of graphs to work out what different values are in a proportional relationship by reading off values from the x or the y axis depending upon the information that we have. Let's move on to something a little bit more complicated. Let's look at the graph now, but y is proportional to x squared. So if we put our constant of proportionality in there, we get y is equal to kx squared. This gives us the opportunity to draw a graph. Here's some examples. Y is equal to x squared. So it's the typical shape of a graph involving x squared, which has a single turning point, and in this case the turning point is at 0, 0. What happens if we look at something like y is equal to 2x? We're changing the coefficient in front of the x squared. So y is equal to 2x squared. The graph for that, well, what happens is it's the same shape, but it's going to be steeper. The arms of the curve are going to close inwards towards the y-axis. And if we look at what happens when y equals 3x squared, we can see that it just gets steeper and steeper as the constant gets larger and larger. So if you see a graph of this shape in a proportionality question, you should be able to straight away work out that there's an x squared involved in there somewhere. And from that, you'll be able to work out what the constant of proportionality is given the information in the question. Okay, let's get even more complex now. We're moving on to y is proportional to x cubed, or y is equal to kx cubed if we put a constant of proportionality in there. And so some example lines. Y is equal to x cubed. Well, that goes from the bottom left up to the top right. It's got that turning point in the center there where x is equal to 0 and y is equal to 0. What happens with a change in the constant of proportionality? Well, as you might expect, the curve gets steeper in the same way that it did with the x squared example. Notice that both arms are moving closer towards the y-axis. Again, if you get a curve that looks like this in a proportionality question, you should be able to work out from that the equation involved there is y is proportional to x cubed. Okay, now for the trickier examples. Y is proportional to 1 over x, or y is equal to k over x. Let's have a look at some example lines again. Well, y is equal to 1 over x. You've probably seen this before. We have asymptotes, so we end up with having two curves, one in the negative x and one for the positive x's. And as we change the coefficient, we can see that in this case the curve gets further away from the y-axis, unlike the other curves we looked at where it gets closer to the y-axis as the k increases. This type of relationship, where y is proportional to 1 over x, is known as a reciprocal relationship, or an inverse relationship. Essentially, as x gets bigger, y gets smaller, and vice versa. Unlike the other direct proportion relationships we've looked at, where as x increases, y increases as well. The shape of the graph shows you that this is the case, where as you move along the x-axis, you're moving down the curve on the y-axis. And for completeness, let's look at 1 over x squared. So y is proportional to 1 over x squared. Very, very similar to y is proportional to 1 over x. The only difference here is that you don't have negative values of y. So let's draw some lines. y is equal to 1 over x squared, pretty much as you might expect. The top right hand quadrant remains the same in all of these examples. The thing to be aware of here, of course, is that the value of y is decreasing very rapidly as x increases because of the square of x involved in the relationship. If you've been listening at all in your science lessons, you will know that inverse square relationships, and that's what y is equal to k over x squared is, an inverse square relationship. These kind of relationships occur all over the place in nature. Probably one you've heard of most is the one where it's to do with gravity, where the further apart two bodies are, the less gravitational pull they exert on each other, and that pull, that force, gets smaller according to the square of the distance that the objects are apart. So that's the inverse square law, very, very important in science and nature. You need to go back over this video and make sure that you can recognize the different shapes of these graphs. This will help you when it comes to working out what proportional relationships exist in questions that you are given. Quite often you will just be given the graph and be told that there is a proportional relationship and you'll need to work it out. Usually this will involve either a straight line or a squared graph, or sometimes the inverse squared graph. Those are the ones that most commonly crop up. Be sure you can recognize them and then work out from the equation y is equal to k x squared, or k over x, what the constant proportionality is given the rest of the information in the question.